Day 287 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again doing daily LeetCode problems, and today we have question number 120, triangle. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description and get you some. Now, let's see what the question says, y'all. Question says, given the triangle array, return the minimum path sum from top to bottom. For each step, you may move to an adjacent number of the row before. More formally, if you are at index I on the current row, you may move to either index I or index I plus 1 on the next row. So it sounds simple enough, y'all, but let's go ahead and look at these examples so we can know what it is that they want us to do exactly, because I understand how just reading the question sometimes can be tricky. So let's see what these examples are talking about. In example 1, we have the input triangle equals a 2D array of integers. First array being 2, second array 3, 4. Third array 6, 5, and 7, and the last array 4, 1, 8, and 3. Now, if you notice, each one of these arrays represent a different row in the triangle, right? So this right here represents row 1, then this right here represents row 2, this represents row 3, and so on, with this being the last row. Now, in this case, the output is 4. Explanation says the triangle looks like this. Boom. The minimum path sum from top to bottom is 2 plus 3 plus 5 plus 1, which equals 11, and it's underlined above. So let's go ahead and look at these underlined integers so we can see what they're doing here, right? So we start at index, or we start at index 0 in the 2D array, right? And that's being 2, right? Now, after that, it says we can move to in the next row, we can move to either index I or index I plus 1. So in this case, this is index 0, and we're talking about inside this array, right? The first row is only one integer, so it has to be index 0. So this index 0, right? So that means the next row we can either go to index 0 or index 1. In this case, we see 3 is less than 4, so we're going to go to index 0, right? So this would be index 0, this would be index 1, or this would be index I, this would be index I plus 1, right here. Boom. So we at index 0, so boom, we can choose between either index 0 or index 1, and we see index 0 is smaller, so boom, we're going to stick with index 0. Now we come to the next row. We can either go to index 0 or index 1. As we can see, index 1 is smaller than index 0, boom, and the second index. But we can't go to the second index because that would be I plus 2. We can only go up to I plus 1. So we could choose between the 6 and the 5. As we can see, the 5 is smaller, which is at index 1. So we're going to stay right here at index 1 and add that to our calculation as well. Then we come to the next row. We can either go to index 1 because that's I, we were at index 1 before, or we could go to I plus 1, which would be 8. In this case, right, well, we're looking up here because this is the array. So this would be index 1, and then the 8 would be index I plus 1. Or excuse me, this would be index I in this case. This would be index I plus 1 in this case. And as you can see, 1 is smaller than 8, so we're just going to go with the 1. Boom. So at the end, now we're at the bottom of the triangle, and this was the path that we took. We went 2, 3, 5, 1. So right here, 2, 3, 5, 1, which is going to equal 11. And that's our smallest, that's the minimum path sum that we can create, and thus the output is 11. So remember, we're returning the sum of the elements that we use. We're not returning the actual elements that we use, meaning we're not returning the 2, 3, 5, and the 1. We're returning the sum of those numbers, which is 11. So let's look at example 2. Example 2 is a little bit easier because it's only one integer, right? So it's only the top row of the triangle. So if in example 2, input triangle equals a 2D array, excuse me, with the array inside of the array being -10, and the output is -10 because all we have is this one integer, right? So it'd be the same as if all we had was 2. All we have is the top of the triangle, which means we have no other elements to add to it. And since there's nothing else to add to it, then that's the smallest, or that's the minimum path sum that we can create. It's just -10, and that's why the output is -10. So now that we understand the question and what it's asking us to do, let's get into the fun part, the actual solution, y'all. So the first thing we want to do is we want to create an array which will store the minimum path sum at each level. So in order to do that, we're just going to come right here. We can declare a variable. We could call it paths. Then we'll say colon. Then it'll be an array of integers. So we open up the square brackets and put int inside. And then we're going to come outside of that and we're going to initialize it by saying equal. And it's going to be an array. Open up the parentheses of repeating colon int.max. So it's going to just be an array of repeating of the most maximum number that the compiler can handle. Then we're going to say count colon up to whatever triangle.count is. So that's how many elements are going to be in this array. So this is going to be an array of integers, right? And just to start, the integers are going to be the maximum integer that the compiler can handle, and there's going to be as many as triangle.count. That's what that means right there. Now we need a variable to track the overall minimum path sum. So in order to do that, we could just come right here. We can declare a variable and call it minimum, and then we'll say set that equal to int.max just to start. It won't stay int.max by the end, but that's just to start, give us a default value. Now we need to initialize the first element or the top of the triangle. So in order to do that, we could just say paths 0, a square bracket 0, is equal to triangle square bracket 0 square bracket 0, because remember it's a 2D array, so we need this array is also, this whole array could be also considered index 0, but then we need the index 0 of the index 0, right? So if this array is the first array in a 2D array, it's the 0 indexed array of a 2D array. Then we need to find the index 0 of that array, right? And that's where the 2 comes in, because that is index 0 of this array right here. Boom. And this array is index 0 of this overall array right here, 2D array right here. Excuse me, come all the way down here. Boom. So now we need to iterate through each row of the triangle. So in order to do that, we could just say for I in 0, 0 dot dot less than up to triangle dot count. Boom. Then we open up the brackets. Now we need to traverse each element in the row. So in order to do that, we could just say for j in 0, 3 dots, dot 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 I. Boom. Then we're going to open up the brackets. Now we need to reverse traversal the index, meaning we're going to go from right to left. So in order to do that, we're just going to say let index equal I minus j. Boom. And now it's time to calculate the minimum path sum from the previous row. So in order to do that, we're going to say let path equal index greater than sign 0, then question mark. Remember, this returns a Boolean. So if this statement is true, then what we are going to do, we're going to say we are going to return the minimum of open. So we're going to say min paths square bracket index, come outside the square bracket, comma, paths square bracket index minus 1. And what this is going to do is it's going to return the minimum of these two values. Whichever this is smaller or this is smaller, it's going to return. But then we're going to say colon, because remember, we're still working with this Boolean, right? So if this is true, we're going to return this right here. If this right here is false, if this is false, then we're going to return this, what we're about to write now. We're just going to return path square bracket index. Boom. Now we need to get the current triangle value, ensuring it's valid beyond the first row. So in order to do that, we're just going to say let current minus I If that's greater than 0, then we're going to say question mark. Once again, we're checking to see if this is true or not. If this is true, then we are going to return triangle, square bracket I, come outside the square bracket, open up more square brackets, index, boom. Or if it's false, we just could return a 0. Now we need to update the path sum for the current index. So we can come right here and we can say paths, square bracket, index, come outside the square bracket and set that equal to current plus path, just like that. Now we need to find the minimum value in paths, which stores path sum at the last row. So in order to do that, we're going to come right here. Outside of this for loop, we're going to start another for loop. We're going to say for path and paths. Then we're going to open up the brackets. We're going to say minimum equals minimum is less than path. Once again, we're going to say question mark. So if this right here is true, it's going to return a Boolean. Once again, if it's true, then we're going to return path. Or excuse me, if it's true, we're going to return minimum, colon. If it's not true, we're going to return path. Then we could just come right here, and all we have to do is return the smallest path by saying return minimum, just like that. So let's go ahead and run it, y'all. See how it runs. Hopefully it runs first try. Let's see. Ooh, we got an error. So let's see what that error says. Sorry, y'all. This should be not equal sign. Not minus sign. That should be an equal sign. So let's run it again, y'all. See what happens this time. And it's accepted. Let's go ahead and submit it. Make sure it stays accepted after we submit it, y'all, because that's what it's all about. And look at that, y'all. 0 milliseconds beats 100% of users with Swift, y'all. Y'all know I love those numbers right there. That's what I like to see. I hope y'all learned something today. But before we leave, make sure y'all get one more look at the code in case you didn't. It's something you missed. Get one more look at it. That's the top part. Boom, that's the bottom part. Read it, learn it, love it. I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.